I work for a company called Doodle. I wrote a book called Python Web Programming. I've been involved with Python for about 20 years. And those 20 years were spent in the United States rather than in the United Kingdom, where I've only just returned to work for Doodle as a developer advocate. If you saw Naomi Cedar's talk this morning, then you should be aware that I'm even older than Naomi. I read the description of the slides and I thought maybe I was a little too ambitious, so I won't be saying anything at all about conda and miniconda, but nevertheless, despite that, you'll be happy to know that the notebook is really, really easy to use and install. Okay, so kudos needs to go to these guys, Fernando Perez and Brian Granger, because they are the current leaders of the Jupyter project as it's become. It started out as the IPython notebook, and I'm happy to say that in July of this year, it was announced that the Jupyter project had received $6 million in funding from a charitable foundation in the United States. So that means that it's actually going to be a well-funded project, and so it's got an assured future. And the Jupyter development, where they've actually refactored the code to separate out various aspects of it from this rather monolithic whole that it used to be, is going to help a great deal. So before we go any further, let's just have a quick demonstration, not this kind of demonstration. So what was supposed to happen at this stage was you were supposed to see a wonderful, lovely, this might just work. Okay, right, so this is the Jupyter console, and this is an IPython notebook. And so basically, it's a way of executing code, but as you can see, there is text, beautifully laid out text interspersed with the code. And the idea is that the code cells, the ones with the in text before them, the code cells can actually be executed. So if I hit Shift-Enter, or if I can just click on the execute button, and lo and behold, the code in that cell has been executed. If I try and execute a markdown cell, then nothing happens, it just skips over it. And as we'll discuss later, there are keyboard equivalents to those things as well. So basically, the idea is that now the Jupyter notebook is split up into separate components, of which these are but a few. There are actually a lot more, but since this is a presentation mostly for people who haven't used the notebook before, I've simplified the architecture. So basically, the notebook clients talk to a notebook server, and there are sessions which the clients can cause the execution of, or cause execution in, running with different language kernels. And so the simplest case that we're going to be considering today is where we have a single network client in the a single notebook client in the web browser talking to a single language kernel. Now, the Jupyter system came out of IPython, and so originally it was just a system for executing Python code. But in actual fact now, it can execute code in many other languages as well. So obviously there's Python available there, but there's Julia, Haskell, well, you can read the list yourself, but there's actually a list of about 40 different language kernels, some of which are still experimental, but a lot of them, like the R language, for example, which is a well-known statistical language, the R language is actually a very well-established kernel. So basically, the Jupyter Notebook is now becoming a tool for developing code in pretty much any language that you like and interspersing narrative with it. So that means that you can actually now write publishable code if you want to, using the Jupyter system. So getting started, well, in the old days, running the old IPython notebook, it was really, really difficult to install, and unfortunately that's given it a bad reputation. But nowadays it's much, much easier than it used to be. If you run in virtual environments, then all you need to do is create a new virtual environment and activate it. install the Jupyter complex into the Jupyter project in there, and that gives you notebook capabilities as well as all the other Jupyter features. And once you've installed it, then you just run the Jupyter notebook. Oh, right, that's now then, how do we go back? There's a little arrow for it there. Yeah, okay. So, yeah, the nice part at the moment, I discovered I like to rehearse things when I do presentations, and I discovered that when I installed a notebook, when I installed Jupyter this morning, I couldn't actually run the notebook because there's a bug which stops it, because for some reason at the moment it's not including the FuncTools 32 module. So you may need to pip install that as well. But once that bug's gone, then so will the need to install that extra module be. So it's intended to be an extremely simple installation. So once you've run that Jupyter Notebook command, you get a console, not this kind of console, but this kind of console. And that opens up, it uses the Python browser module to automatically open up a new browser window, and that shows you the contents of the current directory, which can include notebooks, directories, files of all kinds. So if we do this extremely painful return to the other screen here, you can see that I've got my console here. So I've got directories called, well, let me just enlarge those a little if I can, might make it more readable. I've got directories called data, graphics, and reveal.js. The need for the reveal will be made obvious and will be revealed later. And I've got a few notebooks that I'm executing, and a bit of HTML, and of course, because it's a Python project, naturally, I've got a requirements.txt file as well. So that's what the Jupyter console looks like. And as you can see, well, maybe you can't see because perhaps I've, oh no, on the console, those things aren't present. So right, if we just go back to slides, and we may eventually painfully return to what I'd like you to see. There we go, right. So on the console, there are a number of interesting features. The checkbox at the top there allows you to select all files, but as you can see, each file and directory has a checkbox next to it. And so you can actually select those for various operations if you want. There's a menu that allows you to select all folders, all notebooks, which are .ipynb files, any running folders and so on. And then you can perform actions on those things. The little house icon at the top there takes you back to the directory that you started the notebook in. So you can actually navigate up and down the directory structure quite easily and perform a few simple operations on them. Over on the right, there's a menu that actually allows you, for example, to upload new files into that directory. And you might think, well, you know, when it's all running on the same computer, what does that matter? And the answer is, of course, that file store operations are much more easily accomplished using the command line or the Finder or whatever Windows people use nowadays when everything's running on one machine. But of course, because this is an HTML-based and web-based system, you can actually run notebooks which are on remote servers. And in that case, it's quite useful to have a notebook in your own file store, which you then upload to the server automatically and have it land in the directory that the server's running in. You also have the ability to create terminal sessions, which again, aren't particularly useful on your local machine, but if you're running on a remote server, then the ability to automatically trigger a terminal session on the remote server means that you've got much more control over your environment than you ordinarily would have. You can actually create new text files, and you can edit files, things like that as well, but we won't focus on those aspects of the notebook quite so much. And then there is the ability on the very right-hand side to create a new notebook. So if I want to create a new notebook from my console, all I do is I go there, bring up the menu. In actual fact, nowadays you can have Python 2 and Python 3. You can have multiple language kernels, and you can start up a new notebook in any of your installed languages. I've only got Python 2 installed at the moment, and so you can see that it's just immediately created me a new notebook there. So when you're using the console, all you need to do is to click on the name of a notebook to open it. You've seen me create a new notebook, and what happens when you do that is that the notebook server starts a new kernel session with the appropriate language behind it, and then it creates a new browser window which is connected to that session. So obviously in the case of Python clients, you're creating a new interpreter image. And so you get this new window. It's a very, very flexible system. Okay, so the notebook window is a bit more interesting. There are lots of features there. I'm not going to go through them all because you can always look at the slides if you need them, but you've got the usual save buttons. You can add a new cell below the currently selected cell. You can cut, copy, and paste cells, move them up and down. You can actually execute the current cell and move down. You've seen me move that button already. The status of the kernel is reflected over on the very right-hand side. You see there's that little bubble there, and the bubble goes black when the kernel is actually executing code. Because we can't Control-C a web application, then in that case, there's this little button, the square button there, will actually stop and interrupt the kernel. And many of those things you can actually do from the menu system as well, but we won't be looking at the menu system extensively, although we might just have time to look at a few of the things that it can do. So the server is actually maintaining a bunch of kernel sessions, and the execution sequence is in time rather than space. So if we go back over here, I'll just close my untitled window, and I'll go to the window for my presentation. So you can see there the first cell I executed was numbered 1 by the kernel. I can actually execute it again, and this time, because it's selected, I can execute it by using either Control-Enter, which executes the cell but leaves it selected so that I can execute it again, or I can use Shift-Enter, in which case it goes down to the next cell. So a simple way to scroll through a notebook and see what it does is just Shift-Enter, Shift-Enter, Shift-Enter. So if I set x equals 1 and then I set x plus equals 1, do an augmented assignment of 1 to x, then when we print it, it should be 2. But you can use the arrow keys when you're in cell mode. You can use the arrow keys to go back up. So if I hit Control-Enter 5 times now, then I've actually executed that cell 5 times. I'll use Shift-Enter to execute it a 6th time. And now when we execute this cell, we see that x is 8. So the point that I wanted to make there is normally when you're using the interactive interpreter, you have to actually type your code in. And so there's a linearity in space. When you read the session, basically if it's lower down the session, then it happened later. That association between space and time is lost, or rather is no longer a restriction, as I like to think of it, in the IPython notebook. So in that case, we can actually lose the correspondence. There's no linearity of the code when you're executing the thing interactively. If you just want to go through all the cells one by one, there is actually on the cell menu, there's a run all object that you can select, and it'll just whip through the whole thing and execute every cell in the notebook. Okay, so what's actually happening then is that when you either click the execute button or hit Shift-Enter or Control-Enter, the client sends a message to the notebook server, and the notebook server sends that message, or rather it sends the code from the message to the appropriate kernel, which executes it. So the kernel is maintaining session state for each of the individual clients on whose behalf it's operating. So the language kernel maintains state, but of course you now don't have to execute cells in their natural order. And one of the things that I really like about it is that it means you can very easily just go back up to a cell, tweak the code, and execute it again. And that's something that always used to freak me out about the interpreter. The best you could do was, like for one line of code, you could up arrow back to the code and then edit it. So it's much easier because it's in WYSIWYG mode. And also, whoops, gone onto an entirely non-existent screen there. And also, there are a lot of keyboard shortcuts, because I'm a great believer in ergonomics, and I really don't like having to move my fingers away from the keyboard to the mouse to click on buttons and so on. So most of the things that you can do with the menus, you can also do by using the keyboard. So, for example, I'm sitting at the moment on a markdown cell, and I'm not going to go into markdown. I mean, you're either a GitHub user or a markdown user, or you're not. So if I hit Escape A, then I insert a code cell above. Because I'm now in command mode, as you might think of, it's a bit like VI, but it is modal. So if I type an M now, then it becomes a markdown cell. And if I hit Enter, I go into text mode, and there we are. I just created, whoops, not a very good typist, created a markdown cell from the keyboard. Right, and of course I'll have to execute it to make it appear as markdown. So if you're one of those people who's got great facility with the keyboard, then your productivity writing code in the IPython notebook can actually be pretty high. Oh, I should have mentioned as well that you can bring up with Escape H, you can bring up the whole list of keyboard shortcuts. So it really is quite, it's designed for professional use. Okay, so I personally am of the opinion that that's quite a lot better than the command line, as I've explained why. And another reason that it's much better than the command line is because your output can be much more diverse. So here we can see that I'm actually executing some code. This is matplotlib code. And the graphic that comes out of matplotlib is displayed in line inside the notebook. And again, that's something that can really aid you in your publication. Not only that, but because it inherited its features from IPython, then we have shell escapes and magic. So a shell command is just an expression beginning with an exclamation mark, and so you can actually assign the output, if you want to, from a shell command to a file. So here I'll say, files is equal to bang ls. That says execute the ls command and store the result in files. And so the fact that, because I've just got the expression at the end, that will become the standard output of the cell. And so you can see that that's much easier than using glob, right? All I've done is I've just grabbed a list of the names of all the files in the current directory. There are also magics, and magics are, cell magics begin with 2% signs, line magics begin with a single % sign. They are very well worth investigating, because you can do things like run programs in particular languages, time your code, that kind of stuff, but we don't really have time to go into them. I'll just, whoops-a-daisy, show you a couple briefly. So there, for example, the %, the time it cell magic, I'm just using it to time a loop which takes the sign of 100 numbers, and you can see that we're coming out about 9 microseconds averaged over 10,000 executions, so that's not too bad. Another nice thing is that I can create a file by using the file cell magic. So if you want the reader to be able to see what data you're working with, you can actually create it from the contents of the cell, and it will tell you whether it's written or overwritten the file. So now, of course, I can use, well, if I spell the file name correctly, I just spotted a typo there. So now we can use a shell escape to actually display the contents of that file using the cat command. So I hope I'm giving you the impression that the notebook is extremely versatile. Not only can you do the kind of things we've been talking about with computations as well, but using the cell menu, you can actually say that a cell is either a slide or a fragment of a slide, or that you can skip it. And if you've got the right tool set available, which, or if you know how to use it, NB-convert, the converter now comes as part of the Jupyter suite, then you can actually create reveal presentations from your notebooks. And this is actually a presentation that I gave to the Python London, PyLondon data science group, where I was actually imaging them. So you can see that here my cells are actually just you can do nice things, all the usual nice things that you want to do with reveal. So it's quite a good way to present your results apart from anything else. And with the problems I've had with bloody PowerPoint, I'm beginning to wish I'd actually done this as a reveal presentation, but never mind. Another thing that I'd like to just briefly mention is that the notebooks themselves are data structures. A notebook is a JSON data structure, which means that you can write code to process them. And this particular example, the normalize function, takes an IPython notebook, it goes through all the cells, and if it's a code cell, then it clears the output of the code cell, and it clears the number down so that it's ready for use as a presentation. So we've got a couple of minutes left before time. Just before I go then, it would be nice to be able to show you the IPython blocks system, which is something that was written by a very ingenious guy. And you can see that there you've got a little system where you can draw cells of blocks and do nice things with them. You can kind of animate them. And in fact, the blocks system now has the ability to animate and to flash sequences of blocks. So it's really quite a nice attention-grabbing way of using the notebook. Not only that, but you can actually draw some fairly serious graphics as well. So I'm just stepping through this. So there you've drawn, I mean, the nice thing is you can actually see the pixels there. But the pixels don't even have to be, they certainly don't need to be the same color, but they don't even need to be the same size. So you can actually make each block different sizes if you want. Not only that, but you've got full control over color. And I don't know whether this code is going to work or not. Oh, well, let's give it a try anyway. No, that's not doing any iBlocks things, so there we go. You can actually, yeah, there we go. I was just trying to demonstrate that you can actually animate cells by changing the output of them. I think that does more or less the same thing, but in a rather more rational way. Okay, so I did have some other things, but time has beaten us. So unfortunately, that's going to have to be the end of the presentation. I'm just as keen to hear all the lightning talks as you are. So thank you very much for listening. If there are any questions, I'll be happy to take them. Yes? How do you get your data out? Well, obviously you can write it to files just as you can anything else. So if you're doing matplotlib diagrams, for example, it's very easy to write those to a file with whatever resolution that you want to. But you've got all the standard output mechanisms that are available to Python, including the database API, standard text files, NumPy arrays, you name it, basically. There's no problem getting data out of notebooks. Yes?
Is there a difference between starting it up with a Jupyter notebook as opposed to doing IPython notebook?
Jupyter is in fact just a renaming of the notebook-related portions of the system. So you will find that if you install Jupyter, you can't run IPython Notebook. You have to run Jupyter Notebook, but I think IPython is still available. So no, essentially it's just a renaming. The same functionality is available, but it's been refactored for engineering convenience, because now the team has this $6 million grant. They've realized that they couldn't just all continue to work on a monolithic code base. So they spent about 5 very hard months restructuring the code base so that the individual portions can be worked on separately more easily.
And 5 million on the rebranding.
I beg your pardon?
And 5 million on the rebranding.
And 5 million on the rebranding. No, they're not great. They're not great marketing people, but that's because it's a product that sells itself. You know, you don't need to sell the notebook. It's obvious why you want to use it. Yeah.
What you've been showing us here has been running locally on your computer. How different is the experience on a remote computer?
Well, I mean, how long is a piece of string? That basically depends on how powerful the remote server is and what effective throughput you have to it. But generally speaking, if you've got a problem that needs some really gnarly computation, then it would be much better to spin up in fact, we didn't go into it, but Notebook, the Jupyter system also includes clustering facilities that allow you to do distributed computations over multiple servers. So basically, for development, I always use local servers, but when I've got a really difficult problem, then typically I'll spin up one or more virtuals on Amazon and cluster them together to get the compute performance that I need. But for interactive use, the local machine's usually good enough.
Just quickly, it includes a little editor, which you may have been going to show us, but probably didn't.
Include a little what?
The editor.
Editor.
The editor in Jupyter.
Yeah, sure. I can show you that if you want. Basically, if I go back to my console, well, let me see. I've got a text file there called requirements.txt. So as you can see, I can go along editing it. I mean, it's
right.
Nothing very magical. Yeah.
When you use that, I mean, it's not a bad editor. But it doesn't have a run button, which if it had a run button, then Jupyter could be a replacement for educators that are currently using idle as their main sort of teaching tool. Because if you've got a big lump of Python code in an edited file, it would be nice to be able to press a button and say, run this and put it in a cell as opposed to copy and paste. Do you know if that's coming?
I don't honestly know. In actual fact, the normal way to do that would be to use the Python magic. So you'd edit it in a window, but then in a notebook cell, you would say %Python file name, and it would run that code, and the output would appear underneath the cell. So there are means for achieving the same end, which means that, I mean, I don't know about anybody else, but I don't really, I know beginners seem to like idle, but I'm buggered if I know why, frankly. I think it's an obtuse and rebarbative system. Someone at the back?
Hi. Can you run 2 different notebooks at the same time on one machine?
Can you run 2 different notebooks? Oh, you mean can you run multiple servers? Yeah, I mean, what you're looking at here is, you know, each of those tabs is either a file that's being edited in the notebook. Those are all separate notebooks, right? But they're all running from the same console. Now, if I find yeah, there we go. So what I could do is I could go into, well, I don't even need to go into another one. I can just say Jupyter Notebook again. And lo and behold, up comes a new console. So you can run multiple consoles in separate directories or even in the same directory as I am doing now. So it certainly has the flexibility to allow the same machine to run multiple servers. Yeah.
Okay, thank you.
Pleasure. Of course, you probably twigged that one of the reasons that Jupyter is so popular with scientists is because it actually starts moving them towards reproducibility. And scientists are even starting to use version control systems now, God help us, whatever next.
Sorry. Is there any sense of an ACL on this? Because I notice you have access to terminals, so if you're listening on a port that's open to everyone,
Yep.
Is there a way to kind of limit someone's access to,
Well,
say, the terminal function?
traditionally the security of the IPython notebook system, historically, it's the old story. You know, we'll fix security when we've got the thing working. But in actual fact, during the refactoring, they've produced a component called the Jupyter Hub, and the Jupyter Hub is capable of multiplexing many different servers. So I'm not familiar with the exact details of how the Jupyter Hub works, but I do know that security has been an issue during the refactoring, and that they are taking great pains to try to isolate different notebook users from each other. Although the problem is that the system's actually been designed so that multiple clients can access the same server, so that different people can see, you know, the updated state reflected in there. So when you design a system to be as open as that, then it's hardly surprising that security wasn't as good as it should have been to start with. But then, you know, when you look at some of the vulnerabilities concerning the Docker, for example, and, you know, its root identity, it's certainly no worse than that, and probably a lot better. But they are very aware of the need to beef up the security, and they are actively working on that, yeah.
Okay, cool. Thank you.
Pleasure.
Take one more
Gentleman
question.
on the front row.
Can I check? Has there been conversation about version control support in this? Because something that I find very interesting is the ability to see how something developed over time and the ability to go back. Obviously, you can do it on the file system, but is there an idea of putting it as part of the Jupyter framework?
I've not heard of anything, but I mean, I'm not so intimately involved with the development of Jupyter that I would necessarily know if everything was going, if anything was going on in that area. One thing I definitely can tell you is that originally IPython notebooks were a pain to keep in version control systems. Because, as you can imagine, I mean, everything is kept as a JSON data structure. Those are quite difficult to diff. So the usual standard practice is to use some kind of normalization program like the one I showed, so that all you have is the code cells in your JSON notebook, and it does make them at least, you know, possible to use with Git and Mercurial and other version control systems. But in terms of visibly showing the changes, in actual fact, there is a program called the NBDiff, the notebook differencer, which will do a visual difference between two notebooks, one of which can come out of the version control system. So we're approaching that capability, but it's not an engineered feature yet, I don't think. Good question, thanks. Okay, thanks everyone.